Section 7.2, Sum and Difference Identities. In this section, make sure you have the unit circle handy. And we use these sum and difference formulas to find the angle that isn't generally given in a unit circle. So unit circle, we have values that are of degree 30, 60, 45, and 90, and we kind of recycle based on where it falls in what quadrant those values for sine, cosine, and tangent. But what about values that aren't within those intervals? We can use the sum and difference formulas for cosine. These formulas can be used to calculate the cosine of sums of different angles. For example, cosine, we use alpha and beta, but you can use A and B if you choose not to work with Greek letters. So for example, we have cosine of A plus B equals cosine of A times cosine of B minus sine of A times sine of B. Cosine of A minus cosine of B equals cosine of A times cosine of B plus sine of A times sine of B. Notice that depending if it's a plus or a minus changes what kind of function we have. Notice that we have cosine and cosine and a minus for a plus, cosine and cosine, and a plus for a minus. We have sum and difference formulas for sine. They read sine of A plus B equals sine of A times sine of B plus cosine of A times sine of B. We also have sine of A minus B. That's made up by sine of A times sine of B minus cosine of A times sine of B. And we also have them for tangent. Tangent of A plus B equals tangent of A plus tangent of B divided by 1 minus tangent of A times tangent of B. And tangent of A minus B equals tangent of A minus tangent of B divided by 1 plus tangent of A times tangent B. And again, we use this to find values of degrees or radians that are not in the unit circle. So let's take a look at this first example. Find the exact value of cosine of 75 degrees. And if you look at unit circle, you don't have 75 degrees. But you can create 75 degrees. You can create it by either adding or subtracting values that add up to be 75. So for example, you can go ahead and work with any combination you like. So for example, 45 plus 30, or maybe you'd like to work with 135 minus value, or 225. You want something with a 5 and subtract with it something so you can create that 5. Or not, you can subtract with a 45. But the goal is to get something and something equals 75. It can be a plus, it can be a minus. There is no restriction. But we can use, for our problem, we can go ahead and use 45 plus 30. So we're going to use that 45 and that 30 and our sum formula for cosine. So our formula says, always write down your formula, cosine of 45 plus 30, which is our 75, is equal to, our formula is cosine of A times cosine of B minus sine of A times sine of B. Now, our labeling is that A is 45 and B is 30. Now, because it's the sum, it doesn't matter if we make A 30 and B 45, but with difference, you would have to be a bit more careful. So we want to find, using our labeling, if A is 45 and B is 30, we want to find cosine of, our A is 45, times cosine of our B is 30, minus sine of A 45 times cosine of 30 Sorry, that's cosine. That's sine, not cosine. Sine of b, which is 30. All right, so we're going to find all these values from our unit circles. So make sure you have your unit circle handy and let's evaluate. Cosine of 45 is square root of 2 over 2. Cosine at 30 is square root of 3 over 2 minus sine of 45 is square root of 2 over 2 and sine of 30 is 1/2. And again, we're just looking at unit circle. Remember, x is cosine and y is sine, and we have those coordinate values throughout our unit circle. Okay, so let's go ahead and multiply them out. So 2 times 3, they're within the square root. So I have square root of 6 over 4 minus square root of 2 over 4. So our answer is square root of 6 minus square root of 2 over 4. They have the same denominator, so I can just go ahead and subtract my numerators. This is our exact value. It's not a decimal approximation, it's the exact value of cosine of 75. Next, let's go ahead and find the difference, or use the sum of difference entities to evaluate the difference of sine of 45 minus 30. So we're really being asked to find the sine of 45 minus 30, it's 15. What is sine of 15? Well, we don't know. We could figure it out using a calculator, but we can't find an exact value. So we must use our sum and difference formulas with the help of a unit circle. So we have sine, and then we have a minus. So you want to use the sine A minus B formula to work this out. Oh, and according to our formula, sine of A minus B, look above for your notes. That's sine of A times cosine of B plus cosine of A times sine of B. Now, because of this, we can say that my A is 45 and your B is 30. So let's use that to evaluate. So I have sine, my A is 45. I have cosine of B, my B value is 30, plus cosine of A, my A is 45, times sine of B, sine of 30. And that's about it. And now from here, we just look at unit circle. So we see that sine at 45 is square root of 2 over 2. Cosine of 30 is square root of 3 over 2. Plus cosine of 45 gives us square root of 2 over 2. And sine at 30 gives us 1/2. So we multiply these two, we get square root of 6 over 2 over 4 plus square root of 2 over 4. Our answer is square root of 6 plus square root of 2. We have the same denominator of 4. And that's our answer. Not so bad. But with degrees, whatever we do with degrees, we can similarly apply it to radian measure. So C, using the formula for cosine of the difference of two angles, find the exact value of cosine of 5 pi over 4 minus pi over 6. Now, sometimes when I'm working with values, it's hard to measure radians versus measuring degrees. Degrees, it kind of follows more simply. So if you'd like to, you can always go ahead and change it from degrees to radians or radians to degrees. So you can do that if you'd like. But it kind of already broke it down for us. So all we have to do is use our formula. So we notice that there is a minus, right? A minus sign. So I use my cosine of difference formula, which is cosine of A minus B is equal to cosine of A times cosine of B plus sine of A times sine of B. Now I have the same trigonometry identities formulas that I gave you in your earlier modules. I have it right next to me as I'm working these out because it's so easy to make a silly mistake. So make sure you are helping yourself out to having these out. So your A value is 5 pi over 4 and your B value is pi over 6. Now, if you don't like those values of radians, you can look at your unit circle and see what they are. Or you can use the formula to convert them. So 5 pi over 4 is 225 degrees. And pi over 6, that's just 30. So if you're wondering what we're looking for, we're trying to find the difference between 225 and 30. So we're trying to find the measure of 195, which is not a value in a unit circle. Okay, let's go ahead and finish it off. Cosine of A, so I want cosine of 5 pi over 4. I want cosine of B, my B is pi over 6, plus sine of A, 5 pi over 4, times sine of B, which is pi over 6. Now we look at unit circle and see what these values are. Cosine at 5 pi over 4, cosine at 5 pi over 4 is negative square root of 2 over 2. Cosine at pi over 6 is square root of 3 over 2. Sine at 5 pi over 4 is negative square root of 2 over 2. And sine at pi over 6 is 1/2. All right, let's multiply them. Our denominator is 2 times 2, which is 4. And I have a negative square root of 6 plus denominator is 4, negative square root of 2. So I have negative square root of 6 minus square root of 2 over 4. We have another one for tangent. And for this one, I'll rewrite it for you, just so you can see that it's the same thing if we change it to degrees. So pi over 6, I'm looking at my unit circle, I see pi over 6 is 30 degrees, and pi over 4 is 45 degrees. Now we have a tangent of sum formula. You can hear the paper shuffling because I'm looking at my sheet for these functions. Tangent for a sum, because I have a plus sign. Tangent sum formula is tangent of A plus tangent of B is equal to tangent of A plus tangent of B divided by 1 minus tangent of A times tangent of B. All right, now we go ahead and replace A and B with our value. So my A would be 30 and my B would be 45. Let's go ahead and make that replacement. So I have tangent of 30 degrees plus tangent of 45 degrees divided by 1 minus tangent of A, which is 30 degrees, times tangent of B, which is 45 degrees. Now, tangent at 30 and 45 are actual values. So, luckily they're in the first quadrant, so you don't have to worry about them being positive or negative. In the first quadrant, they're all positive. So, tangent at 30 degrees is square root of 3 over 3, plus tangent at 45 degrees is 1, divided by 1 minus tangent at A, which is 30 degrees. Tangent at 30 is square root of 3 over 3, which we already did, and tangent of 45 is 1. So then from there, we just go ahead and clean it up. So I can write this as 3 over 3. So I can have 3 plus square root of 3 over 3 divided by, on the bottom, times 1 is just itself. I can write that 3 over 3. So 3 minus square root of 3 over 3. Because we have the same denominator on top and bottom, when they divide, they're going to cancel out. So we're left with 3 plus square root of 3 divided by 3 minus square root of 3. Now, while this is your answer, and you're very fair to box and think it's your answer, once you check it in the back of your book, it's not going to match up. Do you know why it's not going to match up? It's your denominator's fault. Your denominator is not rationalized. So we have to go ahead and rewrite it so that it is. So let me write a note about that. So rationalize your denominator, and you do that by multiplying by the conjugate. And I see that your text didn't do that right now that I was checking. But it's something we do in the math community to have some uniformity within our answers. We make sure that there's no square roots, radicals in your denominator. So we have as our answer 3 plus square root of 3 divided by 3 minus square root of 3. Now we must multiply by the conjugate of the denominator. So I have 3 plus square root of 3, 3 plus square root of 3. That's just your denominator with a different sign, so with the plus. We go ahead and multiply. So my denominator, I use differences of squares. So it's your first one squared minus your second one squared. And your numerator, you go ahead and multiply. Luckily, this is just the same thing times itself twice. So you can use a power of 2 rule. So this will be 9 plus 2 times 3, which is 6, square root of 3, plus 3 squared, which is just 3. So I have 9 plus 3 is 12. 12 plus 6 square root of 3 divided by 9 minus 3, which is 6. So I have 12 plus 6 square root of 3 divided by 6. And we can simplify so that we get 2 plus square root of 3 because the 6 divides both the numerator and both terms in the numerator. So what I did here was I thought of this as 3 plus square root of 3 squared, and then I use my expansion rule, or you can FOIL. All right, on to another example. Given the sine of A or alpha is 3 over 5, with alpha being between 0 and pi over 2, and cosine of B is negative 5 square root of 3, with beta being between pi and 3 pi over 2, find sine of alpha plus beta. All right, so this is a common question that you see in the course, and this question really puts into challenge everything you've learned thus far. So for alpha, we're given the value of it, and we're told that alpha has a bound between 0 and pi over 2. So your alpha is somewhere here. And your beta has a similar bound, but it's between pi and 3 pi over 2. So your beta is somewhere here. And you always make your triangle touching your x-axis. Now, this is important because depending on where our angle falls, we know some values of our function based on all students take calculus. So this means that all of them are positive. Here, only sine and its reciprocal cosecant are positive. Tangent and its reciprocal cotangent are positive, and cosine and its reciprocal secant are positive. All right, now here it's telling me that sine is 3 over 5. Sine is, we always have an argument. Sine of alpha is always opposite over hypotenuse. So here we have our opposite value and our hypotenuse, which is 5. So I have 5 and the opposite is 3. Same thing for beta. Now beta is made up of cosine, and cosine is always adjacent over your hypotenuse. So we have our adjacent value and our hypotenuse value. Adjacent is 5 and our hypotenuse is 13. Now our minus goes to depending on the value. Here my x's are negative, so the negative must apply to that 5. Okay, how are we going to use all this? Well, our goal is to evaluate this. Sine of alpha plus beta. To evaluate, I need the equation, which is sine of alpha, or A, times cosine of beta plus cosine of alpha times sine of beta. So I need to take the time to find all of these values. Now, based on what's given, I know, or we know, sine of alpha, so we have that one done. And I know cosine beta, so I have this one done. I need to do the work to find cosine alpha and sine beta. How do I find them? Well, we have the triangle to find them. We just need to find that missing side. How do we find that missing side? We use the Pythagorean theorem. We use a squared plus b squared equals c squared. All right, let me erase all that highlighting. So our goal is to find our missing values. We need to find cosine alpha, and we need to find sine beta so that I can finish off this formula. All right. We're going to find them using our Pythagorean theorem to find our triangle. So let's work with this first triangle. I need to find this missing side. I don't know what that is. Well, we can find it using Pythagorean theorem. So our Pythagorean theorem is a squared plus b squared equals c squared. Our c is always our hypotenuse. We can make that one a or b, it doesn't matter. So we have 3 squared plus b squared equals 5 squared. So I have 9 plus b squared equals 25. So I have b squared, 25 minus 9. Let's move 9 to the other side. And we get 16. So b is 4. Is it positive? Well, I did skip a step. We take the square root of both sides, so I'm left with b is equal to plus or minus the square root of 16. So b, it can be plus or minus 4. How do you know which one it is? Well, you have to look at which quadrant you are. Here, my x's are positive, so it has to be positive 4. So my missing side is 4. On to my other triangle. Similar idea. I need to find that missing side. I know my hypotenuse, so my formula again is a squared plus b squared equals c squared. My hypotenuse is always your longer side, and we're left with the leg. Doesn't matter if it's a or b. So we're left with a squared, which is negative 5 squared plus b squared equals 13 squared. All right, 5 squared is 25 plus b squared equals 169. We subtract 25 to both sides, so we're left with b squared equals 169 minus 25. We get 144. We take the square root of both sides, and we're left with b is equal to plus or minus the square root of 144 is 12. We have to think if it's positive or negative. It's not verbatim. So the value we're trying to find is this b here. well, this missing side, which is our b. We labeled it b, so it's circular labeling. Is it negative or positive? Well, our y's are negative, right? We have -1, -2, and so on. So I have to choose that negative one. So b is -12. All right. Now I can find cosine alpha and cosine beta. All of this work was for our alpha, right? Because this is our angle alpha. And all of this work was for our beta. So we can find cosine alpha and, whoa, lost my notes. Give me a second. There we go. So I can find cosine alpha and sine beta. Cosine alpha, so we look at our alpha. Cosine is adjacent over hypotenuse. Our adjacent is 4, our hypotenuse is 5. For beta, sine is opposite over hypotenuse. Opposite is -12 and hypotenuse is 13. So now we have all of our values. Sine alpha, that was given. That's 3 over 5. Cosine beta, that was given. That's -5 over 13. Plus cosine alpha, we found that. That's 4 over 5. Sine beta, we found that. That's -12 over 13. And we go ahead and clean that up. So 3 times 5, or 3 times -5 is -15. And 5 times 13, that gives us 65. Plus 4 times 12 times -12, that gives us -48. And 5 times 13 again, it's 65. So I have a common denominator. -15 plus 48, we get -63 over 65. And that is our answer. That was a lot of work for one problem. Now we also have some difference formulas of cofunctions. And we can use that to evaluate its cofunction form. So let's go ahead and take a look at this example. So write tangent of pi over 9 in terms of its cofunction. So we have to look what is the cofunction of tangent. And we see here that that is tangent of alpha equals cotangent of pi over 2 minus theta. Our theta is pi over 9. So let's set up our function. Our formula is tangent of theta is equal to cotangent of pi over 2 minus our theta. So for us, this means tangent of pi over 9 is the same as the cotangent of pi over 2 plus pi over 9. All right. Well, cotangent of pi over 2 is, well, let's think about what we're doing. Tangent of pi over 9 is not a value in our unit circle. So we're going to use this to try to rewrite it in another way. So let's go ahead and add these values. So let's get a common denominator, get a common denominator of 18. So I have cotangent of 9 pi over 18 minus 2 pi over 18. So it's the same thing as cotangent at 7 pi over 18. And that just gives you another perspective of looking at the same value. Now we can also use proofs within our sum and difference formulas, meaning I can create a proof and try to prove it using sum and difference formulas. So this first example is asking to verify that the identity sine of alpha plus beta plus sine of alpha minus beta equals 2 sine alpha cosine beta. Now, my best advice when working with proving functions is work with the most difficult looking side. Often it's your more longer, more complex side. Let's start off by expanding these values. So sine of alpha plus beta is sine of alpha times cosine beta plus cosine alpha sine beta. That's my first one. And I have plus, and then I have sine of alpha minus beta, and the formula for that is sine of alpha cosine beta minus cosine alpha times sine beta. All right, let's try to see what we have. So we see that I have cosine alpha sine beta twice. I have it here, cosine alpha sine beta minus cosine alpha sine beta. So they're the same thing and we're subtracting them from one another. So these add to make 0. Now we're left with sine alpha cosine beta plus sine alpha cosine beta. And aren't we adding the same thing to each other? Think of it as x plus x. How would you write that? That'd be 2x. So here we have 2 sine alpha cosine beta. And we see that it's the same thing. So we can prove it, well, we have proved it, saying that sine alpha cosine beta equals 2 sine alpha cosine beta. We're done. All right, that's it. You have more complex proofs in your homework. And my advice is take the moment to expand your formulas, use your formulas, have them handy, have that whole trig identities formula sheet handy as you're working these out. All right, that's 7.2. Thanks.